Okay, so let's go through the homework assignment. How did that go? Easy? Trivial? Yeah, that's the point. All right, so let's look at this. So write a Java program that prompts the user for a decimal number. So we're going to be practicing with our scanner, right? Doing some prompting. And then displays to the screen the binary equivalent as a string. Notice that you must use division, modulo, and concatenation. You may not use any built-in conversion functions. Note that the integer.parseInt 123 will give you the number 123, so you may use that for converting the number read in from the user from a string to an int. Okay, so let's go and write this. Actually, before I forget, let me put Raspbian to sleep from the previous class. Let's open up. And this is homework 3. Okay, so I'll keep doing this. I know some people are still struggling with GitHub, so I'll keep going through the same process that you should probably do for your GitHub. So I'll open up Git Desktop. I'm going to go to File, create a new repository. We'll call this guy CSC250 Fall 2020 Homework 3. And I'll create that repository. So that just created a repository locally on my computer. I don't remember where I put that, but I'll just pretend like I'm creating a new one. Will it tell me downloads? Okay. All right, so now I have a local repository here. I'll go into Eclipse now. I'll create a new Java project. And we'll call this guy CSC250 Homework 3. And for the location, I'm going to choose that folder I just created. So I'll go to location, it's in downloads. And it should be CSC250 underscore fall something or other. And this is homework 3, so there's the folder that I created. So I'll choose that folder. That's where I'm going to store this project. All right, so make sure the location of your project is in that repository folder that GitHub Desktop created. That way it'll automatically manage it for me. Okay. And then I'll go ahead and hit finish. It's asking me about the module. I don't like using the module, so I'm just going to say don't create. Here's my new, here it is, homework 3. All right, so that gets me this folder here, homework 3, and I have a folder for source that's currently empty. I will right click on that. I'll hit new class, because what it's done right now is it's created a project for me, but I don't actually have any Java source files in it yet. So I'll right click on the source folder. I'll create a new class, and I've been calling this guy driver. Hit finish. Gives me something that looks like this. And by the way, for those of you who are noticing this guy up here, it'll disappear in just a minute, actually. Less than a minute. In fact, just for the sake of argument, I forgot to do at the end of my last class. But just so I don't forget, let me go ahead and just upload this real quick. 1520 history of language. Okay. So we'll go ahead and write our quick little hello world program for practice to make sure we know how to write these things and also make sure that our thing is working. So we'll do a public static void main string array args system.out.println world, and we will run that, and there's hello world. So we know we have a working project. I know for some of you, if you've had issues with getting it to run right off the bat, it's because of that module thing. Make sure you delete the module, or like what I just did this time, click the button that says don't create when it chooses to create the module. Something you should see right now is under Git Desktop. This is that repository I just created, this homework 3 repository. Notice it notices some new files in there. So I can actually go ahead right now and I can push it up if I want, and then I'll publish changes. So I'll actually do this 2 separate times so you can see how to update things once if you stop your homework in the middle and then need to do it. So I'll say, okay, everything's good here. So I'll just say initial post, I'll say commit to master. What that does is it commits any of my changes to my local repository here on my computer. All right, so now it says no local changes. Everything's been marked as updated locally on my machine. So now I want to publish this. It'll say publish the first time because right now I don't have that repository created up on GitHub yet. So I'll click on publish repository. It's asking me what do I want the name to be. I'll just leave it as the default name. Make sure you uncheck this box. Keep this code private, uncheck it. So it's a public repository that I can easily see when you submit the link. And then go ahead and hit publish repository. And now it's up there. If I want to go and confirm it, I can go to GitHub. And here is my 250 homework 3, this guy right here. And inside of my source, I should have my driver that just has my hello world program in it right now. All right, questions about that process? So I just took you through the whole process of creating a Git repository, creating an Eclipse project, getting it all working, publishing the repository, pay extra attention not to make it private. That way you can change it after the fact, but if you give me a repository that's private, I won't be able to see it. so then I'll give you a bad grade and hopefully you're checking and then you'll open it up and I can go in and update the grade. But don't make me do that very often. Inconvenient, please. Okay, so go back into our code here. So we want to prompt the user for a number, right? So we're gonna take this one little step at a time. Don't just sit down and write tons and tons and tons of code at once without testing it because you'll run into nightmares with bugs and headaches and things like that. Eventually you'll be able to do that, but for now, just do one little thing at a time. So we're gonna read in from the user, and then we're going to just echo back out what the user gave us. Make sure we have that 1-2 punch working, right? So to read in from the user, we use our scanner. And we're gonna read in from our keyboard system.in. Now we've got the little underlines under scanner. It wants me to import java.util. So I'll import java.util scanner. Just adds a line of code here to the top. You could have written that yourself. All right, and then we'll go ahead and prompt the user. We'll say system.out.print. And we'll say print instead of println just so it doesn't kick it down a line. Doesn't matter, just more trivia type stuff here. So we'll say, please enter a number, because we always want to be polite when we're writing our code. And then we'll go ahead and read this guy in. So initially, I'm going to read string number in input dot, is it next line? Like that. And then I'll go ahead and print it out. System.out.println number. All right, so this program right now should prompt the user, read something in as a string, and then just echo it back out to the screen. Go ahead and run this. Please enter a number. I'll do 35. Press enter, and there's my 35 echoed back out to the screen. But we know this guy is currently a string, because if I instead print out that number plus 6, I would expect to get a 41, but I'm actually going to get 356. Because that's treating that plus sign as what? String concatenation. Plus sign is treated as string concatenation. In Java, unlike Python, only one side of the plus operator has to be a string in order for it to be flagged as string concatenation. In Python, both sides had to be string types. Okay, so not what I want, right? I want to make sure I can do numerical stuff to this value. So what I could do is I can say, I'm going to actually rename this guy. I'm going to say number as a string, just really verbose variable names here. Then I'll create an int, number as an int, and this guy will be equal to integer dot parseInt number as a string. All right, so now when I print out number as an int and I try to add 6 to it, it'll do math. So there's my 41. So now I have the numeric version of that. Okay, and I gave you this tool as part of the homework. I said you can use this guy right here to turn it into a int. You maybe also happen to stumble across, you can say input dot next int. So there's actually a next int function from Scanner that'll let you read an integer in. So you can read it in directly as an int if you want. Just a little convenience thing. Not the way I intended you to do it, but it's fine if you want to do it that way, and you'll see it's still behind the scenes. It's probably parsing it into an int. All right, but my intended solution was for you to do something along these lines. You could have parsed it directly in input.next line. You could have put that inside here and just parsed it as you were reading it in. I just broke it into 2 lines here to exaggerate what we're actually doing. Read it in as a string, then convert that string to an int. All right, so far so good. We're confident that this guy is a number now that we can do number things with. Okay. So now, what are we ultimately doing? We're converting this to binary? Okay, so to convert to binary, what do? We divide it by 2 over and over and over again, recording the remainder, and then reversing it at the end. So we'll do this 2 separate ways, okay? So we'll go ahead and we're gonna say, now when you start dividing it, when you're converting a decimal number to binary, how long do we keep dividing it by 2? Until what happens?
Until the number is 0.
Yeah, until my quotient is 0, right? Until the division part is 0. So I'm going to keep doing something while it's not 0. So while number as an int is not equal to 0, I'm going to do some stuff. Now I'm going to need to collect my answer inside of a string here, right? So I'm going to create a string. We'll call this guy answer. We'll start off as the empty string. That way I can build onto that my remainders, because the concatenation operator only requires one of the sides to be a string. I can add stuff onto the empty string conveniently. Okay, so what I'll go ahead and do is I'll say answer is equal to answer concatenated with the current value of number as an int mod 2. I'll go ahead and grab my remainder. Now, right now I am building it forwards, which will be the reverse of what I actually want. We're doing this one little step at a time. So we're going to see at the end, we almost have the right answer. We have the right answer in reverse. Okay. So I've recorded the current remainder, but now I need to whittle down my number as an int. So number as an int is equal to number as an int divided by 2. Make sense? And this will happen over and over and over again until number as an int is finally a 0. All right, when all is said and done, we'll go ahead and just for right now, we'll print out our answer, which should currently be backwards. All right, and I think for the homework, I use 123 as our example. Okay, so I'll go ahead and run this. 1, 2, 3, and I get 1, 1, 0, 1, 1, 1, 1, which is the correct answer-ish. It's just currently in reverse. Now, when we do this by hand, we usually read it from bottom up. So I can do a couple things. I can either go and reverse this. Can I suspend this? Or what I can do is I can actually build it in reverse. So each time through, I'll tack on to answer my new remainder concatenated onto whatever answer used to be. I'll build it backwards. So I'll have the correct order in the end. One, 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 0, 1, 1. That make sense? All right, does that solve the whole homework assignment? And then we can ask it to put in another number if I want. Pick your favorite, whatever. I'm sure that's right. So I don't want to do the math on it. All right, questions about that code? All right, you want to break it down. It's one thing you want to be able to do is you want to be able to read code. The hope is, even though some of you may have struggled writing this, when you see an answer, it should make more sense to you than maybe when you wrote it yourself. So this creates our tool for reading stuff in from the user. This prompts the user for entering something. This reads it in from the user as a string, which is the default. This converts that string into a number, to an int. This gives me a variable that I'm going to use to build up my answer in. Then as long as my value that I'm going to be whittling down is not a 0, so remember that's the algorithm for it. We keep dividing by 2 until we finally get a 0. That's our stop case. So as long as it's not a 0, what will I do? I will tack on to answer the current value of number as an int mod 2. So I'll get the remainder of it when I divide it by 2. And then I'll actually whittle it down. You need to make sure you do it in that order. If you whittle it down first and then get your remainder, you'll be off a number each time. Okay, so I'm going to record my remainder first, then I'll whittle it down. It'll loop back up. I'll do that over and over and over and over again until I finally get a 0. Then I'll fall past. I'm just going to display to the screen the current version of answer, which I've been building up in reverse already. Cool? All right, so that is that guy. Notice it's seen some changes. So I'm going to go ahead and I'm going to say, call this guy solution for homework 3. And I'll go ahead and commit this to master. So I've added to my code, but I'm going to actually flag this guy as the solution so that when you go and look at it, you'll see this is the solution, because at the end of class today, I'll have some new stuff I'm going to add to the end of this. So rather than creating a new repository, I'll tack it on to the end of what we're working on today, but you'll be able to go back and click on my push that says solution for homework 3 and see the actual answer. Okay. So I'll commit this to master local. So now I've committed it locally, but until it's not updated up in GitHub until I say push origin. Now it's up there. So here's my final version of that. And I should be able to click on, is it the history? Yeah, so I should be able to see my initial post, which just shows this hello world thingy. And then if I want to see my solution for homework 3, click on that and it'll show me this is what I changed to get to that. That makes sense? So that also shows you that these have timestamps, so that if you're sitting in class and you're making updates, when you go to push your updated version to your repository, which is fine, I'll be able to see the version that you submitted before class, as opposed to maybe your updated, hey, I fixed it during class thing. So I won't think you're a cheater because you have my answer up there as your most recent push. You know, because I'll be able to see that you did that after class had gone. All right, questions about any of that stuff? GitHub, Eclipse, blah, blah, blah. So far, so good? Okay, let me just quickly, I want to look, see what we're doing for the next assignment to make sure I get us there. Okay. All right, so let's say, well, first of all, let's move this into a function, because this convert from decimal to binary is something we might want to use often, right? So I'm going to go ahead and I'm going to create a function down here. So this is going to be inside of the class. So this is inside the opening and closing curly braces for the class, but not inside of this method. You'll actually see here that there's a little thing you could minimize your methods. So I can actually create, now it kind of looks like I have the class is kind of like a garbage bag. And inside there, I can have a whole bunch of functions or methods, but you don't put a method inside of another method. All right, so I'm going to make this guy public static. He actually doesn't need to be public, but just roll with it for right now. He's going to return a string because I want him to ultimately build up a string and return it to me as the answer. So public static string, and we're going to call this guy decimal to binary, and he'll take an int number as an int as a parameter. Okay, and then what I'll do here is I'll take my code from up there. This is the logic that takes number as an int and converts it to a string that is my answer. Then I will, because I've advertised and I'm going to return a string. Java is a strongly typed language. So when we write a function, we have to specify what will we return. If we're not going to return anything, the return type is void. If we are going to return something, we have to specify what we're returning. But notice I'm not returning anything in here right now, so Java's not happy. I hover over this, it says this method must return a result of type string. I've gone through here, I've created a string, I've built up that string. Now I'm going to go ahead and I'm going to return that string. All right, so still do the same thing, prompt the user, read in, get it as a string, convert it to an int, and then I'm going to print out the result of calling decimal to binary on number as an int. And I'll get my same answer as before. Oh, whatever. But now it's using this tool here that will convert from a int representation, a decimal representation, into the string version of the binary equivalent. Make sense? Okay, so I have a reusable tool now that I can call whenever I need to take a decimal number and convert it to binary. I can come in here, I can just put a 41 in there, and it will now convert 41. Well, it doesn't matter what I type in here. Well, it does need to be a number. And there's 41 as a binary value. All right, so that's decimal to binary. What other bases might we want to convert a decimal number to? Go ahead. Hexadecimal? Okay, let's do that one last. Give me another one. What's another popular computing base?
Octal.
Octal. So we're going to write a function here. Public static string octal, decimal to octal. And this will take in a int number as an int. All right, go ahead and take a couple of minutes and try to write that function. The function that's called decimal to octal that takes in a decimal number as a parameter and returns a string, which is the octal equivalent of that decimal number. Remember, the legal octets for an octal number are 0 through 7, right? So all these numbers are made up of 0, 1, 2, 3, 4, 5, 6, 7. And instead of dividing by 2, we divide by 8, so on and so forth. But it's the identical pattern to what we just wrote. Okay, take 5 minutes to All right, so let's take a look at this. So I'll start off with our decimal to binary as our base. So we're still building up an answer. We're going to still keep going as long as our number as an int is not equal to 0. Each time through, we're going to tack on something to our answer, but instead of modding by 2, I'm going to mod by 8. And then when I whittle down answer, instead of whittling it down by 2, I'll whittle it down by 8. All right, and that's it. So we'll call this guy on decimal to octal on whatever number we enter in. And let's say we enter in 123. Let's just go through that process here quickly. So 123 from decimal to octal. 123 divided by 8 is 15. 15 times 8 is 120, so I have a remainder of 3. 15 divided by 8 is 1, with a remainder of 7. 1 divided by 8, 8 goes into 1 0 times, with a remainder of 1. So our answer should be, from reading from bottom up, 173. Go ahead and run this, put in a 123, and we get a 173 as our answer. That make sense? So my code here is identical to what we had for decimal to binary, except I modded by 8 and I divided by 8. Well, this guy's the same. I just called my decimal to octal function instead of decimal to binary function here. That's what thing I changed up here, just to test it. But I can call both of them. So if I want to see what it is in binary and in octal, there's 123 decimal. There it is in binary. There it is in octal. All right, so let's look at the next obvious choice. Well, less than obvious choice. Decimal to decimal, which you might say is a complete waste of time, but should still work. I've advertised that we have this one pattern that will convert from decimal to any other base, right? So decimal to decimal should record the remainder by 10 and should divide by 10. So decimal to decimal, if I test that one, this should give me the binary, then the octal, then the decimal version of whatever number I put in. So I'll put in 123, I get the binary, the octal, and the converted decimal number, 123 as a string. Make sense? Pattern still works? All right, so now, decimal to hex. hexadecimal is what base? Base 16. So I would mod it by 16, divide it by 16. Is this guy good? Do I need to make any other changes? What are the legal hextets of the hexadecimal number system?
0 through F.
Yep, 0 through 9, A through F. Okay, so this guy right here is not necessarily the value I want to tack on. It's the numeric value, right? If it's a 7, I can tack it on. If it's an 8, I can tack it on. If it's a 9, I can tack it on. But if it's a 10, I want to tack on an A. If it's an 11, I want to tack on a B, so on and so forth. If it's a 15, I want to tack on an F. So we are looking for a solution here where instead of just haphazardly taking that value and concatenating it onto my answer, I need to make sure that I convert it to the proper hextet before concatenating it on. So for 0 through 9, I can leave it alone. For 10 through 15, it needs to be A through F. All right? So understand where our point of weakness is here? So take a couple minutes and try to think through a solution to map that numeric value to the appropriate hextet. A 0 becomes a 0, a 1 becomes a 1, an 8 becomes an 8, a 9 becomes a 9, a 10 becomes an A, an 11 becomes a B, a 15 becomes an F. Make sense what I'm asking you to do? Okay, so take a couple minutes and try to modify this guy to give us the right answer. And if you want to see it currently giving us the wrong answer, I'll do decimal to hex. And I'll choose my favorite conversion, 2989, which should give me BAD. And we're going to see that this guy currently gives me, doesn't matter what I enter in here, an 11 for B, a 10 for A, and a 13 for D. Correct values, but I haven't converted it to the right hextets. So we're going to need to do some magic with that piece right there. Take a couple minutes and take a stab at it. All right, so let's take a look at this. So what we're going to do, I mean, and there's some crazy ways you could look at this. You could say something like, maybe you just do a int temp is equal to this value. And then you might say that, well, if temp is less than 10, then we can go ahead and concatenate it on. Else if temp is equal to 10, answer is equal to A concatenated with whatever answer currently is, and then B, C, D, E, F, so on and so forth. So you could certainly pull it off that way, right? Here, I'll just do some copying and pasting and finishing it. Okay, so we can do something like that and get it accomplished. There's our BAD. You can imagine for larger bases, things might get a little bit more verbose, but this will get the job done. Now, if you didn't want to be as brute force as this, we could be a little bit fancy. Maybe I create a string called map, and I put into the string all the hex stats from the hexadecimal number system. Something like that. And then what I do here is I concatenate on answer is equal to map.charat temp concatenated with answer. If temp is a 0, what value is at bucket 0? A 0. What value is at bucket 1? A 1. What value is at bucket 9? A 9. What value is at bucket 10? An A. Bucket 11 is a B. Bucket 12 is a C. So on and so forth. So I can also accomplish it using this, the charat method of the string class, to just look up a numeric value at a particular place. There's also my BAD. Make sense? Okay. Let's see. Have we talked about arrays yet in here? The conversion from lists to arrays? I see it in the slides. We talked about it here? Yay, now I'm getting nothing from the audience.
Yeah, I think we have.
Okay, good. So then let's look at a for each loop. And we can do a couple different things. Let me go ahead and push this. So update for more conversions, including. So I'll commit that to master and then push origin. So now that's up on GitHub as well. Okay, so what I'm going to do here is I'm going to gut most of this. All right, and we'll go ahead and we'll create a string and also an array. So I'll say string s is equal to elephant. And I may have already done this, but let's just get it out there as something that can go through multiple collections. I actually think we saw that we can't iterate over a string if I remember correctly. So say not iterable, right? Yeah. So I would have to say s.toChar array to accomplish that. And we'll say system.out.println. I do remember this from our first thing, but let's just get it out there so we can do some stuff with for each loops if we want to, and also get it up on GitHub. So I'll go ahead and print out C. So create a string S. We can convert that to a character array, which is something we can iterate over. So this is kind of like saying for C in S, if we're in Python. And this will let me go through that entire collection there. But I can also, and we're going to go and we're going to look at this in integer arrays because we want to start trending towards searching and sorting and things like that. So I'm going to go ahead and create an int array called AR, and this is going to be a new int array, and I'm going to put 100 things in there. Okay. Now, we might want to fill this up with some random stuff. So I'm going to go ahead and I'm going to create an instance of the random class. I'm going to say random r is equal to new random. So this is something that lives inside of the java.util, the same place scanner lives. So I'm going to highlight over this. It's going to say import java.util.random. I'll go ahead and get rid of the scanner because we're not using it right now. All right. Now I'm going to go ahead and I'm going to fill up my entire array with random numbers. So we'll go ahead and say for int I is equal to 0, I is less than ar.length, I++, and we'll go ahead and say ar at bucket I is equal to r.nextInt. All right, and I'll go ahead and just because this is going to be handy for me soon as we start getting into the searching, sorting stuff, I'll go ahead and I'm going to create a function called print int array. This guy will take an integer array AR, and he's going to go through and print all the values of that integer array to the screen. So I'll go ahead and I'll say for int I in AR system.out.println I. So then down here I can say driver print array AR, and this will print me 100 random integers. Okay, so the random class by default, which we may or may not have already looked at, but doesn't matter, we'll review it here again, gives me a integer. So when I say r.nextInt, this is an instance of the random class calling its nextInt function. This guy gives me an integer, a random integer in the range of all integers. How big's an integer? How many bits are integers in Java? A byte is 8 bits. A short is 16 bits. How big's an int? 32 bits, right? So what's the smallest value that can be represented in a 32-bit number? -2 to the 31st power. And what's the largest value? +2 to the 31st power. Okay, there's a little bit of a wiggle room in there. It's -2.1 billion to +2.1 billion with one extra value on the negative side. And that's from something called 2's complement that you'll learn about in the 325 class, the way that negative numbers are represented. But in any case, basically positive or negative 2 to the 31st power. Okay? So that means every single time I call r dot nextant, I'm going to get some value between negative 2 billion and positive 2 billion. Now, what if I wanted to have a value between 1 and 15, using only what I've shown you so far, which means that you're only allowed to use this version of the nextant method. So you have to generate a number between negative 2.1 billion and positive 2.1 billion and somehow get that whittled into a number between 1 and 15. How could you do that? How could you take a number in the range of negative 2.1 billion to positive 2.1 billion and force it to be in the range of 1 to 15? Can we get rid of all the negative numbers? How do you make a negative number a positive number? This is just normal math. This isn't a Java thing. If I have negative 7, I want it to be positive 7, what do I do to it?
Multiply it by negative 1.
Multiply it by negative 1. Okay, so I can get a value here. Int temp is equal to r dot nextant. All right. Now, I only want to multiply it by negative 1 if it's a negative number. How do I ask if temp is currently a negative number? What does it mean for a number to be a negative number?
If 0 or if temp is greater or less than 0.
Yeah, temp is less than 0. That means temp's a negative number. I'll say temp is equal to temp times negative 1. So at this point in time, when I get to this line, I'm guaranteed that temp is now a positive number. It either was randomly a positive number to begin with, or I've intervened and made it a positive number, right? So now temp is between 0 and 2.1 billion. A couple lines of code, I've cut 2.1 billion options, took them off the table. Okay, so now I have a number between 0 and 2.1 billion. How do I get it to be a number between 1 and 15? What can I do to the number 164,258 to force it to be a number between 1 and 15?
Mod it by 15.
Okay, mod it by 15. So temp is equal to temp mod 15. That will guarantee now that temp is in what range? Modding by 15 says I'm going to divide it by 15 and record the remainder. So the maximum remainder you can have when dividing by 15 is a remainder of 14. So this will give me, this is guaranteed that temp is a number between 0 and 14 right now. I want it to be a number between 1 and 15. How do I do that?
Mod it by 16.
Well, if I mod it by 16, now what is it? A number between 0 and 15. I want it to be 1 to 15.
Mod it by 15 and then add 1.
Mod it by 15 and then add 1. So let me just say temp plus plus. So now temp will be a number between 1 and 15. You know, your brother does the identical thing. Did you learn it from him or did he learn it from you? I had no idea. Identical thing. He just did his little clap thing and even the same cadence. I'll have to text him later. All right, so now we have a bunch of numbers between 1 and 15. All right, so we see that we can use a random number generator to give us random numbers in a tighter range by just doing some math manipulation to it, right? And none of it was hard math, but what did we see here? You know, this goes back to, you know, week 1 of CSC200. We remembered something. We asked some questions, right? You know, we were technically in the middle of some repetition here. We're going through every element of AR.length, so we're doing this some number of times. Get a big number, make sure it's a positive number, whittle it down a little bit more, modify it as necessary. Now, how else could I have done this? What if I wanted to give myself an alternate approach to this? I would call it a worse approach. Could I, if we treat R dot next in as kind of like a giant dice roll, you know, we have the 4 billion sided die that has numbers between negative 2.1 billion and positive 2.1 billion. Could I just keep rolling that die over and over and over and over again until I just get a number between 1 and 15? Sure. So I'm going to use one of my loops. Do I have to roll it at least once to get my initial value, right? So I'm going to say int temp. And I'm going to say do temp is equal to R dot next in. And I'm going to keep doing that over and over again while temp is outside of my range. So while temp is less than 1 and temp is greater than 15. So I'm going to roll that dice over and over and over again with one of 4.2 billion options each time. So it's 2 to the 32nd power is 4.294 billion. So 4.294 billion sided die. I'm going to roll it over and over and over again until I get it to be one of those 15 values. And I'm going to do that 100 times. So we're asking the moons to align, right? But are we guaranteed that by the time I exit this while loop, temp will be a number that is greater than or equal to 1 and a number that is less than or equal to 15? It will be. How long do you predict this program is going to take to run? Hold on a second. We shouldn't have that range. Give myself a variable temp, give it a value, as long as, so while temp is less than 1, oh, or, need to have an or. We actually don't know how far in we're getting yet. So what I'm going to do here, just to give ourselves a little preview, I'll print out temp after we exit that while loop each time, just so we kind of see how long it's taken to get out of there. Ah, got one. It's like that, like Powerball. Oh, look at that. Really need to wait for it to do it 100 times. So probably not the most efficient way of accomplishing this, right? Random numbers, and I'm sure I talked about this last semester as well, but I'll remind you now. Random numbers are actually a very interesting part of computer science, in that getting true sources of randomness is considered to be a very, very difficult thing to do. You know, which in a interesting Christian worldview perspective kind of points towards creation, I think. You know, that it's hard to find things that are truly random. Everything has some sort of sense behind it. kind of a fascinating thing. There's a whole research area in computer science around what is true randomness, and it's hard to find. Okay, so I think we see where this is going, right? Eventually it's going to fill this thing up, but not nearly as quickly as we kind of wanted it to. But now we have the ability to have some random numbers. But what I'll do is I'll go back and I'll throw one last little loop in here just to introduce a, so I can say I want int temp to be equal to r dot nextInt, and there's a version of nextInt that says, give me the range of values that you want it to be. The second number, I believe, is non-inclusive. I thought we had a range. Oh, with bound. So we can say I want to give it, I think it's, if I give it to 16, that'll give me 0 to 15. So if I give it to 15, that'll give me 0 to 14 plus 1. Will give me my full range there. So this is a quicker way of just saying, give me values between 1 and 15. So we can use the version of nextInt that takes in a single parameter, which is the maximum bound of that value, not inclusive. And this will return a number between 0 and 14 in this case. And then I'm adding 1 to it. That'll give me my 1 to 15. All right. So there's our convenient ways of dealing with random numbers. So ultimately what we're left with here is a bunch of data that is unsorted. So one of the things we're going to be working with in this class over the next many weeks is looking at various algorithms for taking unsorted data and making it sorted. So even though that concept is something we've maybe done before, now we're going to be looking at known algorithms for actually accomplishing this concept, going from less efficient but easier to understand to more efficient and a little bit more complex to understand. We'll also be looking at searching algorithms for accomplishing the same thing. Let me kind of go through here real quick and just see, make sure we have all the things crossed for the homework. So done that, done that. Already did that one. Well, this one stands on its own, it's fine. We wrote a function. So this is going to be our homework assignment for next class. So write a function in Java that takes a string representation of a binary number as a parameter and returns the string representation in hexadecimal equivalent. So going the other direction to what we did today. So we went from decimal to other bases today. For the next assignment, you're going to go from another base back to decimal. But notice this guy does, you're going to have to do both sides of it. So this is going to take in a string representation of a binary number. So you're going to read in a number like 10111, and it's going to convert that to a hexadecimal number. Make sense? All right, so a couple different ways of doing this, but the most straightforward brute force way of doing this is going to be to first convert the binary number into decimal, and then take the decimal number, convert it into hexadecimal, which we already wrote today. You could also write this using the shortcut. I would encourage you to write it both ways, okay? But at least one way is good enough. But effectively, we're reading in a binary number and outputting the hexadecimal equivalent. You can decide which approach you want to take. We'll write both of them in class on Thursday. All right, questions about what I'm asking? All right, I'll put this up on Blackboard, and I will see everybody on Thursday. I'll make sure I push the latest version of our code, whatever it is.